Hello guys, welcome back to lesson number 5 of the Basics of Mechanics lecture series. I am Bharani Deepak, and in this series we are learning the fundamental concepts of engineering mechanics. In previous lectures we have learned about Newton's law of motion, various type of force systems, how to resolve inclined force into horizontal and vertical components, and also we learned how to calculate the resultant force of a system. If you are not familiar with the concepts that I have just mentioned, click on the video link in the description below to get yourself familiar. Now, what we have done less is we haven't yet solved any problems with the concepts we have learned. So today I'm going to discuss with you a few engineering mechanics problems and we are going to solve them together. Now don't be under the impression that I'm going to keep on writing steps after steps during problem solving. What I will do is I will discuss a few new concepts and think along with you as I work out the solution. So let's begin. First problem for today is determine the magnitude and direction of the force F is equal to 2I plus 3J. Now F is equal to 2I plus 3J is a vector form of representing a force. Here I and J are unit vectors of say X and Y axis. So from the looks of it, F is represented as a combination of unit vectors of I and J alone, which means F is a two-dimensional vector. So we can actually do a graphical representation of it. To do that, let's first draw our axis. Now we have assumed that vector I correspond to the x-axis. So 2 times I is somewhere here, and the unit vector j correspond to y-axis. So 3j will be along y-axis. And finally the force will be directed somewhat like this. So once we draw the force, we can now move on and try to make a right angle triangle like this, with its side correspond to the magnitude of the unit vectors in horizontal and vertical direction. So considering the angle of inclination of force as theta, so this is theta, the opposite side will be 3 Newton and the adjacent side will be 2 Newton. Alright, now with this we can easily calculate the magnitude and direction of the force using the formula which we discussed in lecture number 4. So for a right angle triangle formation, we have R, the magnitude of the force F, is equal to square root of Fx square plus Fy square. In this case, Fx is equal to 2 Newton and Fy is the vertical component, this is 3 Newton. So we would get 4 plus 9, which is root of 13. So the magnitude of force F is equal to root of 13 Newton. And the formula for angle theta is equal to tan inverse of Fy divided by Fx. So when we substitute the Fy and Fx in this formula, we get tan inverse of 3 divided by 2. So theta will be equal to 56.30 degrees. And that is how we can calculate the magnitude and direction of the force given in vector form. Now before moving forward, let's see about equilibrium and let's also discuss the conditions of equilibrium. Okay, so what is equilibrium? Equilibrium is actually a state of a body when the net force and the net moment acting on the body is zero. In this simple example, if you calculate the net force acting on this block, you will have 0 Newton as your net force. So when net force acting on the body is 0, it represents that there is no resultant force acting on the body, and therefore for an equilibrium system there will be no resultant force. Now coming to the conditions of equilibrium, well, it's fairly simple, right? The net horizontal force summation of Fh must be equal to 0 and net vertical force summation of Fv must be equal to 0, and also the summation of all the moment acting on the body must be equal to 0. Now if you're wondering, moment is a twisting effect caused by two forces which are not in line with each other. We will learn about this in coming lectures. Okay, now that we have learned the conditions of equilibrium, let's look at this problem and solve it. Determine the tension in the cable BC and AC which holds 45 kg of mass. Here you have two cables AC and BC which are tied to this mass of 45 kg. And at the same time there is a pull of 450 Newton in the horizontal direction. The first step to solve this kind of problem is to simply represent the system as a free body diagram, where you replace cables and masses into simple particle and forces like this. The mass of 45 kg is now been converted into force by multiplying it with the acceleration due to gravity. Remember the Newton's second law. Also note that the direction of the tension force will always be towards the fixed support. To calculate the tension on the string, or rather on the cable, you must consider that the system is in equilibrium. So for an equilibrium system, we have summation of Fh is equal to 0 and summation of Fv is equal to 0. So as we can clearly see from the free body diagram, we do have horizontal and vertical forces, but the tension force which we need to calculate are inclined at some angles. And we need to compute the horizontal and vertical components of these tension forces. You should be in a position to do this by yourself by now. If not, then go check out lesson number 2, where I have clearly explained how to resolve an inclined force into their horizontal and vertical components. When you resolve the tension force F1, you should get the horizontal component as F1 cos of 30 and vertical component as F1 sine of 30 degrees. So doing the same for the tension force F2, we will have the horizontal component as F2 cos of 30 degrees and the vertical component as F2 sine of 50 degrees. This must also be 50 degrees because the angle of inclination for F2 is 50 degrees along the x-axis. So now by simply applying the conditions for equilibrium, we will have summation of Fh is equal to F1 cos 30 degrees plus F2 cos 50 degrees is equal to 450 newtons. Substituting the value of cos 30 and cos 50, we will have 0.866 times F1 plus 0.6427 times F2 is equal to 450. Also summation of Fv, summation of all the horizontal forces, of summation of all the vertical forces is equal to F1 sine 30 degrees plus F2 sine 50 degrees is equal to 441.45 Newton. So here again, substituting the value of sine 30 degrees and sine 50 degrees, we will have 0.5 F1 plus 0.7660 F2, which is equal to 441.45 newtons. This is also newtons. Now we have two equations and two unknowns. So when we solve the system of simultaneous equation, we will have F1 is equal to 178.30 newtons and F2 as 459.92 newtons. So from this, the tension force AC will be 178.3 newtons and the tension force BC will be 495.92 newtons. This is how we can make use of the equilibrium condition to solve real problems. It's also not that difficult, right? Now in the next section, we will learn about Lami's theorem and we will solve a quick problem using it. Lami's theorem can be used for a system in equilibrium with three forces. Also, this force system must satisfy certain conditions. First, the three forces must be coplanar, which means they all must lie on same plane. Then they must be concurrent, which represent that they have same point of application. And then they must be non-collinear, which means they must not share same line of action. If these terms coplanar, concurrent and collinear seems odd to you, you should check out lesson number 3 where we had already discussed them in detail. Alright, so what does Lami's theorem says? Well, it gives the relationship between these three forces which are concurrent, coplanar, non-collinear and are in equilibrium. And the relation is expressed as A divided by sine of alpha is equal to B divided by sine of beta, is equal to C divided by sine of gamma, where A, B and C are the magnitude of the forces and alpha, beta and gamma are the angles between them. So with this relation, given the angle and magnitude of two forces, we can calculate the magnitude and the angle of the third one. We can apply the Lami's theorem in this example here. A 10 kg lamp is supported by two cables AB and AC. What is the tension in each cable? So as always, let's first draw our free body diagram. But before that, we need to calculate a few things. First, let us convert the mass in kilograms into weight by multiplying it with 9.8, which is the acceleration due to gravity. We will get 98.1 Newton of weight acting downwards. And to calculate the angle between the three forces, we need to know the angle ABC and angle ACB. So let's apply trigonometry and find out the angles. In the right angle triangle ABD, let's call this as D, this point, we have AD is equal to 0.75 meters and BD as 1.5 meters. Calculating the tan of angle ABD, we have, so tan of angle ABD is equal to 0.75 divided by 1.5, and angle ABD is tan inverse of 0.75 divided by 1.5. Angle ABC is 26.56 degrees. Similarly, when we calculate the tan of angle ACD, we have 0.75 divided by 2, and angle ACD is equal to tan inverse of 0.75 divided by 2. So solving this, we will get angle ACD is equal to 20.55 degrees. Now we have the angles that we needed, and let's redraw this system of forces. So the weight of the lamp will act in this direction, which is 98.1 Newton. This will be the tension on the string AC. So this is TAC, and this will be the tension on the string AB. So this will be TAB. Now we had this angle, and this is what, 26.56. So this angle will also be 26.56, but we need this particular angle, so we need to add 26.56 with 90 degrees, and therefore we'll be ending up with 116.56 degrees. So similarly, we had this angle, which is 20.55. So this will also be 20.55. To get this whole angle, we need to add 20.55 with 90 degrees. So here as well, we will end up with 110.55 degrees. And this is easy to find, which is nothing but 360 minus 116.56 minus 110.55, which will be 132.89 degrees. Now this formation is ideal for us to apply Lami's theorem, so let's do it. So when we apply Lami's theorem, we will get TAC divided by sine of 116.56 degrees will be equal to TAB divided by sine 110.55 degrees will be equal to 98.1 newtons divided by sine of 132.89 degrees. Solving for TAC, we will get TAC is equal to 133.89. This is nothing but this term here times sine of 116.56. So TAC will be 119.76 newtons, and solving for TAB, we will have 133.89 times sine of 110.55. So TAB will be 125.37 newtons. So these will be the tension forces acting on the cable which are supporting the lamp with mass 10 kg or with weight 98.1 newtons. So that's it for today. I hope you learned something new and are following along. If you learned something from this video, consider giving a thumbs up and subscribe to the channel. Also share it with your friends who might find it useful. I will meet you guys again in the next lecture. Bye bye.